right, again, the game plan is to go through chapter 12 today, then next week on Tuesday, do a demo and try to see if we can do the Joes using Eclipse, and then a week from today, lecture on chapter 13, then give you at least a week of lab. Then after that, go through chapter 14, which is on applets, and after we get done with that, we're going to go into the Android stuff. So it'll be somewhere around week 9 or so, okay? All right. And a comment was made to me by somebody who shall remain anonymous today. I want to make sure you understand that when you're doing the homework for chapter 11, not only are you supposed to be doing validation, you are supposed to be writing exception classes. Not just validation. You are supposed to be writing your own exception classes. That's part of the grade. All right. So, that said, we're in chapter 12 of 14 that we're going over. And I'm going to give you a quick little history thing. You may or may not care, but you get to hear it anyway. As they say in Java, you use the Java Foundation classes. In the olden days, like back in the 2000s, in the 1990s, virtually everything you wrote, and really the 80s and 70s too, you used what's called the AWT, the Abstract Window Toolkit. The problem with that is Java's mantra has always kind of been that what they wanted to do was write once, run anywhere, and they wanted it to look the same when you created an application. They wanted it to look the same regardless of the operating system that you were using. Well, that didn't work very well because, as an example, when you create buttons in when you create buttons on the Mac, they're automatically rounded by default. Whereas in an Intel platform, they're square by default. And people didn't like that. So what they decided to do was they decided that in addition to the Abstract Window Toolkit, they would create something that was called Java Swing classes. The other thing to realize, and they'll get into this a little bit in the book, is that the way that these classes, that the AWT was set up, all right, they were basically, they took a lot, they were called heavyweight components. So they would require a lot more precision, whereas when they went to Swing, they're lightweight components. Typically they will render faster, they will render better, they will be truer, you know, and they will look more the same amongst different types of operating systems and different platforms, etc. All right. So a lot of new terminology in here as far as it says a window in a GUI commonly consists of several components. So in this chapter we're going to talk about most of the stuff you see here. Buttons, labels, text fields, checkboxes, and radio buttons. All right. And some of the stuff that's in here you'll be able to very easily equate to other things that you've done, other classes that you've had. Some of them are going to be a little bit different. I will tell you, if you care, that there is a program at the end of this chapter, and it's Barney's Bagels or something like that. And I've gone over it in the past with classes, but we're not going to today. And this, it doesn't look that different than this. But the reason I'm telling you that is what's kind of neat about it is they really walk you through step by step on how to build it. All right? So I think we know what all this stuff in here is. Notice that in Java, it's called a text field. Not a text box, it's called a text field. All right? So what I just gave you this stuff about AWT and Swing, so you can go read that on your own. Again, I hate reading out of a book to you. So, all right. This is all, again, about event-driven programming. So the idea is you click a button, you want the button's click event, you know, to fire, and you want to put code under there to make it do something. Same kind of stuff that we've looked at in other classes. The way we code it will be different, but the ideas are the same. Now, all of the stuff that's in there for event handling, what are called event listeners, and you saw these in the class on Tuesday. If you remember, we had calc button listener and we had exit button listener. All those listener classes, they're all defined under the AWT. That's why you still need that AWT.event.star. That's why you need that. But typically when you create new applications now, you use the Java Swing components. And that's why you need the javax.swing.star. All right? And I just want to make sure that everybody gets this. I know we've said this before, but it's been a while. And it may not sound like it's an important thing, but if you ever go into it where you're doing Java programming, it could become an important thing. And that's this. Right, again. So there's a difference between, between this and this. All right. When you put in there import java.awt.star, all that does is it brings in all the classes immediately under the AWT. Immediately. And one of those classes is event. But it doesn't bring in the classes under event. See what I'm saying? Any class that gets created from there. And Java did it like this because they didn't want it set up where you could do this. And there were a lot of people who wanted that. Just give me every frigging class that, or package that there is here, and, let the system figure them out. All right? But they didn't want that to happen. That's why you can't do that. But I just want you to realize that this gives you a bunch of stuff, but it doesn't give you this. It doesn't go down that far. And they mention that in here a little bit, but it's more or less in passing. All right? Okay. So, again, you can use swing classes to create different kinds of components. Let's take a look at some of the terminology that they have in this second last paragraph on the page here. A window is a component. Because a window contains other components, it is most appropriately considered a container. A container is simply a component that holds components. All right. In GUI terminology, a container that can be displayed in a window is known as a frame. You may or may not remember, but when we did that program the other day, we extended JFrame. That's what they're talking about. That's the swing part of a frame. All right, the swing version of a frame. Again, a frame appears as a basic window that has a border around it, a title bar, a set of buttons for minimizing and maximizing, and a closing the window. So in other words, by default, it's just a square. And then in the upper right-hand corner, you've got the X to close. You've got the whatever it is for, minimizing and maximize. What is it? Minimizing is a minus sign, and whatever the hell it is for maximizing. Okay? That's it. That's what you get by default, nothing else. Now it says there's a number of steps involved in creating a window, so that's what they show in this example here. And first they're going to show you the, quote, bad way of doing it. Then they're going to turn around and show you the, quote, good way of doing it. And you might say, well, why would he do both? I don't know Gaddis, but I believe the reason that he's doing this is because you'll still find both of them out there in actual applications. All right. They look very similar. There's just a couple changes. The first thing that you may or may not have noticed is when we look here, for the height and the width, we just set up constants. You don't have to do that. But when you start drawing windows, you do want to give it a size. In other words, rather than calling it window height and window width down here, we could have just passed in 350 and 250. Does that make sense? But if you decide after you've done that, or you're going to use that in more than one place, all right, you usually see it set up like this as far as being set up in constants. All right, so that's the first thing. Then notice, create the window. Okay? JFrame window equals new JFrame. All right? Now, what you're going to see in just a couple minutes is there's the other way of doing it. It's going to look a little nicer, I guess, than this does. All right? So it's window.setTitle, window.setSize, which is that size right there. You see it, the title is a simple window. Window.setDefault close operations, which means when you click that X, close. And window.setVisible is true. And that builds that. Not very grand, not very glorious. All right? And it looks like a lot of work. But again, this is something we've taken for granted because whenever you created programs under .NET, they've already been done. You just sit there and you choose that you want to create a form. Boom, the form's there. Now we have to create it ourselves. So again, they talk about the JavaX swing and what this stuff is. There's nothing in here I don't think we haven't already talked about. That thing where it says the title, a simple window, that's it right there. All right. So then they say, there's actually a better way of doing it. And that better way of doing it is the way I did it with you on Tuesday, and that is to extend the JFrame class. All right. And notice here, what they have that's different is extends JFrame. We don't have all that window dot something. You see that? Down back when we looked at the other one, we had to create the window object, Then it was window.setTitle, window.setSize, window.setDefault, close operation, window.setVisible. But when we extend the JFrame class, all right, all we do is we set the title, set the size, set the default, set. So it's not window dot, because since we're extending the JFrame class, we already have that available to us. That's almost always the way it's done. That's the way it's always recommended that you do it. All right, just a little bit less code. So again, they talk about the extending here. We all know what that means already. The height and the width, all the stuff that you saw before. All right. Now, with the other one, with the first one that we just looked at, come on. All right. We came down here and we said window.setVisible true. In other words, that was the whole program. We put it all inside of main. All right. In the second example, rather than putting it inside main, notice it's public class simple window extends JFrame, and we don't have a main in there. Rather, we write a main that just tests it by calling it. And I think it was Zane that asked that question the other day, as far as, you know, with the Joe's thing, and Mike had asked this morning too. He said, where's the main? And since it's only one line like this, all right, we just put it in the other file. You could have done that in here too. All right, but they just decided to put it, you know, into two for whatever reason they did. And then they'll put it in here. Then they embed it later. So there it is. All right, and they call that an embedded main because technically, when you look at it, it's not a demo class like we had before. All right, so embedding or equipping classes with the main method, you can put them right in there. It doesn't really matter. All right, so that's just a couple things, but now it's the stuff that we should be more familiar with. So notice, if you want to draw things, if you want to create an application, and you want to use the old-fashioned way of doing it, so you want to use AWT for everything. I don't want you to do that. I want you to use the swing because that's the way you're supposed to do it today. But notice, if you put in labels, they're labels. Text fields, they're text fields. Buttons, they're buttons. Notice when you use swing, they put the J in front of everything. Other than that, they look the same. And again, if you're going to use this, you need the javax.swing.star in order to be able to use anything that's in here. This stuff is all in the AWT.star. Okay? And it's totally legit to mix and match. I don't know why you'd want to do that, but you can mix and match swing components with AWT components. I don't know why you would do that, but again, it's not that you can't do it. All right. So what they do throughout the chapter here is they're creating this program that will calculate a distance that you put in kilometers and tell you the equivalent number of miles. So they draw it out here and they say, there's your label, enter a distance in kilometers. There's your text field, all right, and there's your calculate button. Pretty simple, okay? But they mentioned that before you can go on with this, and this is where it gets a little bit different because, again, this is all stuff that you took for granted, or at least I did, in the .NET world and the Visual Studio world that we've got to do in here now. It says before we start writing code, you should be familiar with a couple concepts, those being content panes and panels. A content pane is a container that's part of every jQuery object. The thing is, with a content pane, technically, it's invisible. It's an area that you draw in, but you don't see it. All right? And it says it does not have a border, but any component that is placed in a JFrame must be added to the content pane. Why? Because that's the rule. You say, well, we didn't do it in that first example. You should. It's because we didn't put anything in there. We just were creating the actual frame object. A panel, as it says, is also a container that can hold components. Unlike JFrames, panels cannot be displayed by themselves. They're typically used to hold and organize collections of related components. All right? Now, I want to show you real quickly why you might want to use something like this. I'm just going to draw a simple picture on the board, which may or may not make sense. All right? If you remember the other day, when we were looking at the Joe stuff, one of the things I mentioned to you was up here, there's your north panel up on top. All right, on the bottom, that's our south panel. On the left, that's our west panel. To the right, that's our east panel. And everything in here is the center panel. Okay? The problem is, if you go in and you put something in here, by default, if you're putting it in the center panel, everything's going to be centered, which may or may not be what you want. Does that make sense? You might want to put stuff in here that you don't want centered. It's a centered component, but you might want the stuff that's in there to not be centered. So right now, this is one panel. But what you can do is you can create another panel inside of here. Again, remember, they're invisible. And then you can say the stuff that goes in that panel, rather than having it have a border layout like this, for example, yeah, this is still the center. But what I could do is I could set it up so it was under a grid layout. So you can embed layouts within layouts. Not only can you, quite often you do that. All right, and we'll, if there's time, we'll look at that example that's at the end of the chapter and spend a little bit of time on it just so you can see that in action, so to speak. So as it says, with Swing, you create panels using the JPanel class. In this kilometer converter application, they'll create a panel to hold the label, the text field, and the button. All right, then they'll add the panel to the content pane. So again, they're creating something invisible to add it to something invisible. You know, that sounds a little weird, but that's just the way that it's set up in here. All right. So notice our variables. In particular, look at the first one. Private JPanel panel. All right. That's creating a reference, as it says, to the panel. The rest of the stuff that's in there should make sense to everybody. Okay. So notice, we set our title, we set our window size, we set our default close operation. But then notice what we have. We have to build the panel. And after we build it, we have to add it to the frame. And then we display it. So these are actually done in here, these two things, the build and the add, as two different methods. So as it says, the build panel method adds the label and a text field and a button to the panel. So if that confuses you, I don't think it does, but you're adding this and this and this. And remember, the way that this is set up is if we don't give it any kind of layout manager, it defaults to a flow layout. All right? And you might say, well, big deal. One of the reasons they set the width and the height like this is so it looks like this. You can set the width and the height and not allow the user to change the size. Did you hear what I said? You can set the width and the height and set it up so that the user can't change the size. Well, how would you do that? Well, I take those buttons that are up there that minimize and maximize, I can gray them out, can't I? And then you can't change the size. The reason I'm telling you that is if, you know, so the only thing we have over here is the X, but if we had a maximize button and we clicked it, now the calculate button is going to move up on the top and it's not going to look the way we want it to look. All right. Okay, so as we come in here and do this again, there's the label. So that's creating a label, but it exists kind of in purgatory. It is nowhere right now. We've created a new label, and notice it's an object, so it's new label, and that's what it's going to say, and it's going to be called message label. All right, we do a text field, and notice we put a size in here, so that's just the width. That's not how many characters we can type in it. It's the width of it. All right, and it's a text field, not a text box, and that's how we create the button. Then we create the new panel. We could have created the panel first. It doesn't matter. Then we have to add the components to the panel. So you've got to create the panel first. Then you add the components that you've already created to the panel. All right. So what we basically have done after we do that is now we've got this. It's not operational yet because we have to put some code in there to handle the button. But right now, that's pretty much what we've done thus far. And that's what they explain. All right. So when you get done, this is what you have. Again, the thing to understand is that's what you have, and you can put something into that text field. But if you click the button, absolutely nothing is going to happen because there hasn't been any code put in yet to make something happen. So we're going to have to set up a listener for that button, and then tell it how we want it to, what we want it to have happen when the button's clicked. All right, so that's what we're going to do fairly soon. Again, the author mentions kind of what I told you before, that that's why they made it 310 by 100 pixels high. So if you maximize it, it wouldn't look goofy. All right, 771 here. Handling events with action listeners. And I should be keeping up in the book too, just in case I need it. So. Again, this is an event-driven language. And an event is something that happens in the program. Sometimes you can cause events to happen. If you set up a timer in a program, you're setting up that event. And then the timer goes off and that's an event. You're the one who clicks a button to make an event happen. You can set up events so that every single time, if I wanted to be really, this would take some coding and it would probably drive most people nuts. But I can go into a text field and I can set it up so it checks it a character at a time. So if I tell you to enter, for example, a monetary field, all right, so I'm telling you to enter a number, whatever, your age. I can literally set it up so that if you put anything that's non-numeric in there, it just doesn't even take it. You can hit the letter J as many times as you want and nothing will happen if I want to do that. And that's by working with the correct event. All right. So as it says, what happens when an event is generated by a source component? It's possible that it's connected to an event listener, which, as it says, what it sounds like. All right, it's an object that responds to it, listens for events, and then it reacts to them. And the way this language works, and many languages work like this, just kind of imagine that your program is running, and there's like a little man or a little woman who's sitting there waiting for stuff to happen. And when something happens, that little man or that little woman goes and looks through the series of stuff and says, oh, you click that button, I want you to do this. And that's basically what the program is doing while it's running, is it's awaiting data from the user. It's awaiting input so it can do some processing on that and probably give you some output. And that's what they're saying in here. All right. When the event takes place, it typically is, as it says there, it's referred to as being an event firing. Okay. All right. So we saw this last time, but I really didn't go over it. This is one of those things I said we'll talk about in more depth and breadth of coverage in class. This is an example here, right there. That's an example of nested classes. That is a class within a class. You'll notice that private class inner is inside of public class outer. I told you this back last semester, which you may or may not have remembered, but when in Java, the way that it's set up is you can have only one public class in a file. That public class has got to be the same name as your .java file. So this would have to be in a Java file that was called outer.java. But inside of that public class, you can have as few as none, and as many private classes as you need to have. All right. So as it says, when the inner class is private, it is accessible only to code that contains it. So in other words, anything that you define in here is only known there. All right, but the stuff that's in here knows about the stuff from its parent. Does that make sense? So the parent doesn't know anything, any of the intimate details of the child, but the child knows all the details of the parent. All right. And they mentioned this is not the only way to write event listeners, but it's the way Gaddis decided to do it. Good, bad, or indifferent. All right. Now, when you do this, and event listeners, as it says, must implement an interface. This isn't hard, but it's a pain in the butt because sometimes they implement one interface and sometimes it's another interface. And kind of remembering which one is which. If you do the wrong one, you're typically going to get, you'll get like the underlines and whatever. And if you go to the quick help, it'll tell you the right one. All right. So we're going to get into it a little bit more depth in just a second, but just so you see this. As it says, Java provides all sorts of interfaces that you can use with your event listener classes. And think about all the different stuff that can happen. There's button stuff that happens. There's mouse stuff that happens. There's keyboard stuff that happens. All right, I'm sure that I'm missing something. All right, but even those, click, double click, mouse up, mouse down, mouse over. All right, those kind of things. All of those have got. Your radio buttons have got stuff. Check boxes have got stuff associated with them, etc. So as it says, as you can see, the action listener interface contains the header for only one method, action perform. In English, what they're saying is, if you're going to create something that's of type action listener, you must have that method in there. Okay, and if you say, I don't get it, you're going to see examples of it in just a couple minutes. You must do that. All right. And this is another one of those that's under java.awt.event.star. That's why you have to import that particular package. All right. So this is the kind of thing that we're going to do. This is the kind of thing we did the other day. You may or may not remember it. But for that calc button listener and for that exit button listener, we wrote something that looked just like this, except it said private class calc button listener implements action listener, and private class exit button implements action listener. So buttons, if you look up on the screen here and you look at what's in blue, buttons have to implement action listener, and buttons must have an action performed event. Okay? And it's just something that you have to commit to memory. Or if you say, well, I can't, then you have to be able to get to that page in the book. All right. Notice what it says. When you write a class that implements an interface, you're promising that the class will have the methods specified in that interface. The one that's specified is that one there. This is what it looks like in Java. And we want to implement that interface. And it says, if you're going to implement it, you have to agree to have that particular method in it. Okay, which, again, bottom line is, if I want to be able to do something with buttons and handle the buttons click event, I need to put something like that in there. If you keep that in mind, you'll be fine. All right. To use these, as it says, once you have written the class, you have to create, sometimes they call it wire up, the object of that class, and then connect it with the GUI component, and you do that by doing what's called registering the class. So the code that's in here is literally almost the same as the code we looked at on Tuesday, except the button names were different, but the idea is the same because we were doing the same kind of stuff. All right? So they're going to write an event listener for the kilometer class. So in other words, when you click that button, you want something to happen. Ideally, what we want to have happen is that's a number of kilometers. We want to click the button, we want to convert the number of kilometers to the equivalent number of miles, and then just show a J option pane, message dialog on the screen. That's what the program is designed to do. All right. So again, we're importing java.awt.event.star, as it says for our action listener interface, javax.swing.star for the swing stuff we're putting in here. So they're just adding to it. This is the same program that was in here before. So I just want to concentrate on the new stuff, which is right there. There's adding that action listener. And again, we did this on Tuesday. Is there anybody who's in this room right now that was not here on Tuesday? All right. I gave you a copy already, and there's a couple extra up here. This is that Joe's Automotive that we did. And you'll see that when you look at Joe's. We added two action listeners. We added one for calc button, which we called calc button listener, and another one that we did for the exit button, which was called exit button listener. So that's registering that button. And the other thing is, since we put that in, now what we said is we must have a class inside of here that's called calc button listener, and it must implement action listener. That's what this line of code there means. And there it is. Now, the code that's in here, you should all be able to understand this, all right? Because it's, it's just, it's just natural code that you've used before. In other words, what do we say? Okay, well, here's our action perform. All right, there's conversion because we have to multiply kilometers by 0.6214 to get the miles. There's our input. There's our miles. All right, notice when you want to grab something out of one of these text fields, you've got to use get text. Anybody want to take a wild guess? If you want to put a value into a text field, what do you use? Set text. So get text to grab something out of a text field, set text if you want to put something in a text field. All right? And then we do a parse double on that input. So whatever we put in there, we multiply it by 0.6214, stuff that into miles, and then print out. X number of kilometers is X number of miles. So if we run it, I thought they had a run in here. Maybe they don't. There it is. So if we put 2 in there, 2 kilometers is 1.42. And again, we could set up a decimal formatter class if we wanted to on this to make it just 2 decimal places. I don't think that was his intention one way or the other here. All right. So again, as he always does, and that's one of the reasons I continue to use this book, is he gives programs that I think are sensible. They're programs that you might actually use. And then when he gets done with them, he explains everything that's happening in here. All right. Again, you like his verbiage better. I just, you know, I can't believe it when I walk by classrooms here and I listen to teachers read out of books. All right. I always wondered, did you actually read it beforehand, or are you just going through it now yourself? All right, because I don't know. Now, they do mention this here, that it says, if you want to, it says we could have written the following 2 statements as one statement. So you can combine these 2 lines here and here, if you want to, into just this. I could care less. If it makes more sense to you to do it as 2 different statements, do it as 2. If it makes more sense to do it as 1 statement, do it as 1. All right. This might be one of those things on page, what is it? It looks like 804, but I don't think they map up perfectly, do they? No, 777, that you might want to annotate in your book, because you'll forget how to do this. I still do. All right. Then the author digresses a little bit. If you count right here, there's 13. The author starts talking about colors. These are Java colors. All right. These are the built-in 13 Java colors. You notice it's color with a big C, dot, and then the actual name itself is a constant. Since it's a constant, it's in capital letters. You can, if you want to, if you don't like these colors. All right. You can still use things like RGB. I don't know if there's a way to do it in here. Maybe they even mentioned it in here with the hex colors, but I know RGB works in here. All right, but these are the 13 built-in colors. And as it says, you can set your background and you can set your foreground. And they give this next program. If you run it, it's one of those programs, and this is not a joke because I don't think it's funny, but it's one of those programs, Color Window, that, first of all, if you see it in your book's in black and white, so it's not going to show you much. But as you guess, it's set up that you click a button to select the color. So if you click red, the screen turns red, and the background of the screen turns red. If you click blue, it turns blue. If you click yellow, it turns yellow. All right, does that make sense? All right. I've had people do this in the past. In the first week of class, in the C# class, we'll just go and build a simple program that will have a white form and a red form and a blue form. All right, and you can either have them as 3 different forms, or you can just take the regular form you have and turn it red, white, and blue. Okay, and that's kind of what they're doing right here. So you should be able to look at the stuff that's in here. Again, the new stuff is the colors, but you should be able to come in here and figure out what's happening. Again, when we click on a button that says red, all right, notice we've implemented in here red button action listener, blue button action listener, and yellow button action listener. And they're all doing basically the same thing. Panel.set background to color blue. All right. Panel.set background to color red. Panel.set background to color yellow. And then they try to come up with where it says set foreground, that's setting the text color. All right. So they say if you've got a yellow background, let's have black text. If you've got a blue background, let's have yellow text. And if you've got a red background, let's have blue text. Okay. Again, it doesn't do it a lot of justice to see that. All right. Any questions on any of the stuff so far? Hopefully you find it fairly straightforward. Again, it's different because when you're in the world of .NET and you're using Visual Studio, this is all done via drag and drop. Now you've got packages that you can use like Eclipse, which allow you to do drag and drop. But back in the day, the 80s and and some of the 90s and that's how people created all this stuff. They had the good news is they had total control. The bad news is they had to write a lot of code. And believe me, when we get through this chapter and we get in the next chapter, it's much worse for like creating menus. You've literally got to create the menu. You know, you've got to create every option that's on there. This is all code. You have to use mnemonics if you want the underscore to work, so it's a big pain in the butt. All right. All right. The action event object next on the bottom of 782. As it says, the action listener's action perform method has a variable that's declared as follows. You've seen stuff like this before, where when we worked with the exception handling, but it was something, you know, it was some kind of a message event or something, whatever, that was called event message or whatever the heck it was. So as it says, action event is a class defined in the Java API. When the event occurs, the object is created, and what does it do? Whatever you program it to do. All right. Now, you're going to either like this or not like it. It doesn't really matter. But you've got two different ways that you can do this. Okay? And it's get action command, okay, and it's get source. What's the difference? We're going to talk about them right now. Basically what it is I think it's the action command, but I could be wrong on this. If I'm telling you wrong, I'm telling you backwards, but I'm just doing this off the top of my head. I think with get action command, it does it based off of, are you listening? Based off of the text that's on the button itself. You understand what I'm saying? But when you do get source, that's the name of the control as you defined it in code. You see the difference? So you can do either one. All right, so why would you want to use get action command? Well, if you name all of your buttons, button 1, button 2, button 3, that's not very descriptive. That's a little hint. You should not do that. All right, then you might want to use the get action command. All right, so as it says, the first method listed, somebody let me know, please, when it's 1:50 and we'll take a break. The first method listed returns the action command that is associated with the event. When the button generates the error, the action command is the text that appears on the button. So I did get it in the right order. All right. So again, the idea is, going back to this example, here it's going to be red. If we do the get action command, red and blue and yellow. But if we look at the names of them, when we created them, they were red button, blue button, and yellow button. So if we use the source, we're going to use those. If we use the action command, we're going to use these. Does that make sense? There's not really an advantage of using one as opposed to the other. I think it more is what you have the comfort level with. All right. Some people will tell you that if you use these, since that's the actual code on there, on your buttons, all right, that's easier because it's more self-documenting. I would look at it this way. I use the get source all the time. I just do. But one of the reasons is it is possible that I'll decide I'm going to change what these buttons say. But once I create the button, I'm probably not going to change what it's called. That's my rationale, again, whether that's right or wrong. So again, they show you how to do this, and they come in here, and they're saying if the action command equals button 1, do this. So that here, there it is. Button 1, button 2, and button 3. So with the action command, they say if that's what the face of the button says, button 1, then say you click you click the first button. If you click that one and you're using the action command, since it says button 2, say you click the second button. If you click that one and you're using action command, it says you click the third button. All right. You can either look at it that, you know, these are just really kind of bizarre examples, or they're really good examples because it's very simplistic, but he's showing you exactly what would happen. All right. So again, and here, now notice what they have. So if the action command equals that, and I think then they go back and rewrite the same program. Could be wrong. Yeah, there's the source. So you see the difference? I don't care which one you use. You better use one of them if you want it to react and do what you want it to do. All right, and this all goes under your action perform, but you can do it either way. Again, you can even combine and use some get source and some get action command. I find that confusing. But if you really wanted to do that, you could do that. All right. All right. this actually is a pretty good place to break right here. So when we come back, we'll talk about layout managers. So I'm on page 787, it looks like, in your book. All right, we still got a little bit to go over. Not too bad. We'll get it done by the end of class.